Hi, good day everyone. This video is about the basic properties of logarithm. Number 1, so we have this first property that is logarithm of b with the base of b and that is equals to 1. Right, so for our first property, so if we want to transform this given logarithm into its exponential form, so that is equals to, again, that is our base raised to our exponent which is 1 and that is equals to b. Right, so by using one-to-one properties, so again, since we have this given exponent for this b as 1, automatically our first property is correct. Right, so let's try to answer some set of problems. Number 1, for example, let's say we have this example number 1. Say we have this logarithm of 4 with a base of 4. So automatically, since we have this common base, okay, we have this 4 as the logarithm of a number, and that is equal to its corresponding base, automatically the answer for this given problem is equals to 1. Right, so if you want to double check your answer, so for checking, so let's transform this given expression, logarithmic expression, into its exponential form. So that is copy the base, right? So we have 4 raised to 1, our exponent. We have this given exponent, and that is equals to the number or the logarithm of a number. So 4 raised to 1 is equals to 4. So obviously, this one is correct, and that's it. So the answer for this given problem is simply 1. Okay, so that is our first property. Next, for our second property, we have this logarithm of 1 with the base b, and that is equal to 0. Right, so let's try to double check. So let's transform this given logarithmic expression or function into its exponential form. So let's copy the base. Right, so copy our exponent. We have 0 as our exponent, and that is equals to the number or simply 1. Right, so again, according to the rule or according to the properties of exponents, any number raised to 0 except 0, the answer is always 1. That means we have this correct set of property. So let's try to solve an example. So for example number 2 for this given property, so for example, let's say we have this logarithm of 1, okay, with the base 3, right? So obviously, again, according to this property, since the logarithm of a number and that number is 1, automatically the answer is 0. Right, so let's try to double check our answer. So for our checking, okay, so let's transform this given logarithmic expression into its exponential form. So copy the base. We have 3, and our exponent, we have 0. So 3 raised to 0, and the answer is the logarithm of a number. So that is what? So automatically, 3 raised to 0 is equals to 1, and 1 is obviously equals to 1. So that is true, and our answer is correct. Okay, so that is for our second property. Next, for our third property, we have this logarithm of b raised to x. Okay, so we have this exponent, okay, logarithm of b raised to x with the base b is equals to x. Right, so for this given problem, so let's transform this one. Let's double check our given logarithmic property. So again, copy the base, and that is raised to our exponent, which is x, and that is equals to the number, which is b raised to x. Obviously, we have this b raised to x is equals to b raised to x. So that is equal. That therefore, we have this correct property. So again, using the one-to-one property for exponential functions, if we have this common base, just equate their given exponents, right? So let's try to answer this given problem. So for example, number 3, let's say we have this logarithm of 2 raised to 5. Right, so we have this 2 raised to 5 with the base of 2, and that is equals to what? Right, so again, for this given property, so it looks like we need to cancel out this same set of base. Okay, so we have this base and this number, therefore the answer is equals to 5. Right, so that is our property letter C. So let's try to double check our answer. So for our checking, again, let's transform this given logarithmic function into its exponential form. So let's copy our base. We have this base as 2, right? So that is 2, and our exponent is 5. So 2 raised to 5, and that is equals to the number, which is 2 raised to 5. So obviously, we have this equal expression. So that is correct, and the answer is correct. Okay, that is our third property. Next, for our fourth property, so if the value of x is greater than 0, then we have this b raised to logarithm of x with the base b is equal to x. Again, for this property, we have this given exponential form, right? So we have this base, and we have this given exponent written in its logarithmic form. Okay, so we have this exponent as logarithm, and that is automatically equals to x. So if we want to double check this given problem, so let's transform this exponential form into its logarithmic form, right? So that is equals to logarithm. Okay, so we have this logarithm of the answer. Okay, so the answer is x. That means we have this logarithm of x, and we have this base. So our base is b, okay, and that is equals to the exponent. So our given exponent for this given exponential form is logarithm of x with the base b. Obviously, we have this equal set of expressions. So that is for our fourth property. So let's try to solve some problems using this property. So for example, number 4, let's say we have this 6. Okay, we have this 6 as our base. Okay, 6 raised to the logarithm of 3. Okay, with the base 6, and that is equals to what? Okay, since we have this expression again, if we have this common set of base, so our first base is 6, and the base of its exponent written in its logarithmic form is also 6, so that is equals to 6. Automatically just cancel out this set of values. Okay, and the answer is simply 3. Okay, so that is our property number 4. So if we want to double check our answer again, so let's check our answer. So checking. Let's transform this logarithm exponential, by the way. Let's transform this exponential form into its logarithmic form, and let's try to double check. Okay, so that means we have this logarithm of the a number. So a number is 3. Okay, that is 3. With the base of our base for this given expression is 6. The base of 6 is equal to the exponent. So our exponent is simply logarithm of 3 with the base of 6. So let's copy that. So that is logarithm of 3 with the base of 6. So obviously, we have this equal set of expressions. So automatically, since that is equal, we have this correct set of answer. That is 3. Okay? So this time, let's try to answer some set of examples using this set of properties. Again, we have this 4 set of properties, right? So let's try to solve some problems with use of this set of properties. Number 1. Okay, so for example, number 1, for example, we have this logarithm of 10, right? So let's try to answer this. Okay, so since we have this logarithm of 10, automatically this example is an example of common logarithm. Okay, so it is common logarithm. Automatically, we have this base as 10. So if you want to rewrite this one, this is actually equals to logarithm of 10 with the base of 10. Okay, so this is actually equal, or we can actually use our first property, okay, which is if we have this equal set of base, automatically the answer for this given problem is equals to 1. Okay, so that is according to our first property. So again, just cancel out this set of expressions. So since that is equal, automatically logarithm of 10 is equals to 1. So that is our answer. Okay, next. So for example number 2, right? So for example, we have this natural logarithm, or ln, of e raised to 4, and let's try to find out its value. Okay, so again, for example number 2, we have this ln of e raised to 4. Again, we have this ln, or simply natural logarithm. Okay, so again, natural logarithms are logarithm with the base of e. So if you want to rewrite this given expression, that is simply equals to logarithm of e raised to 4, right? So since that is a natural logarithm, we have this base as e. Okay, so automatically we have this Euler number, or e. So again, with the use of our third property, okay, so that is our property letter C. Okay, so if we have this common set of base, okay, automatically the corresponding exponent is the answer. Okay, So since we have this same set of e, automatically the answer is simply 4. So let's try to double check this one, okay? So um if ln of e raised to 4 is simply equals to 4, let's try to double check. So for our checking, let's transform this one into its logarithmic form. So that is equals to logarithm of e raised to 4 with the base of e. And according to our answer, the value is 4. So we have 4. Alright, so let's transform this again into its exponential form. So if we have this given problem, automatically copy the base. Okay, so just write our exponent. So we have this exponent as 4. So we have e raised to 4. And copy the value. Okay, so the logarithm of a number. So that number is e raised to 4. So we have e raised to 4. Since that is equal, automatically we have this correct set of answers. So the answer is simply equals to 4. Right? So that is our example number 2. Next, for example number 3. Right, so let's try to solve this one. For example, we have this logarithm of 10 raised to 6. Okay, logarithm of 10 raised to 6. Again, example number 3 is an example of natural logarithm. Or, sorry, that is a common logarithm. Okay, we have this invisible 10. Okay, for this base or the base of this given problem. So since that is logarithm of 10 raised to 6, so it is actually equals to logarithm of 10 raised to 6 with the base of 10. And since we have this common set of base, automatically the answer for this given problem is the exponent of our 10. Okay, that is equal to 6. So that is logarithm of 10 raised to 6, and that is equal to 6. Right, so again, same procedure. If you want to double check your answer, for our checking, let's transform this given expression or logarithmic expression into its exponential form. So we have this invisible 10 as our base. So invisible 10 raised to the exponent. We have this exponent as 6. And that is equals to the logarithm of a number. And that number is 10 raised to 6. Obviously, that is equals. Therefore, we have this correct set of answer. The answer is simply equals to 6. Okay? Next, for example number 4. So for example number 4, let's try to solve this one. Say we have this logarithm of 64, right? So with the base of 4, so what will be the value? Okay? Again, since you want to apply this set of properties, I think let's try to apply our property letter C. Okay, we have this logarithm of a number, and that number is equal to the value of our base. Since the value of this expression, we have 64, and the value of our base is 4, let's try to transform the value of 64 into its exponential form. Okay, and let's transform this value with a common base, with use of 4 as our base. So let's transform. That means I think that 64 is equals to 4 raised to 3, I think. So 4 raised to 3 simply equals to 4 times 4 times 4, and that is simply equal to 64. Right? So let's rewrite this one. That means logarithm of 4 or logarithm of 64 with the base of 4 is actually equals to logarithm of 4 raised to 3. Okay? We have this same set of value. Okay, we use this value with the base of 4. Okay, again, according to our third property, if we have this given set of values, we have this base which is equal to the logarithm of the number. Automatically cancel out this one, and the value is the exponent, and that is equals to 3. Okay, so if you want to double check your answer, again, let's check this one. So let's check. Let's transform our original expression into its exponential form. Okay. Again, let's copy our base. We have this base is 4. And that is raised to our answer. Our answer is 3. And that is equal to the logarithm of the number, which is 64. Right? So let's double check. So if we have this 4 raised to 3, that is simply equal to 64. And 64 is obviously equal to 64. If that is correct, automatically our answer is also correct. Okay? That is our example number 4. Next, example number 5. So for our example number 5, let's say we have this exponential form. Let's say we have this 8, okay, raised to a logarithm of 4, with the base of 8. Okay, so what do you think? What will be the value? Right, since we have this given value, okay, I think that is actually applicable for our fourth property, or property letter D. So if x is greater than 0, automatically we have this if we have this common set of base, the answer is the exponent, or the value of the logarithm. Okay, so for example, for this given problem, again, we have this 8 as our base, and the base of its exponent is also 8. If that is equal, the answer is the logarithm of the number, right? So that is equals to 4 automatically. So let's try to double check this one. Okay, let's try to transform this exponential form into its logarithmic form. That means that is equals to logarithm of a number, okay, and that number is simply 4. Okay, that is 4 with the base of, our base is 8, with the base of 8, and that is equals to their exponent, and the exponent of this given problem is logarithm of 8, or logarithm of 4 with the base of 8. So let's copy this one. That is logarithm of 4 with the base of 8. So obviously we have this equal set of values. Since that is correct, so our answer is also correct. So we have this answer as 4. Okay, that is according to our property letter D. Okay, next. For example number 6, again, I encourage you to pause this video and try to answer this one on your own. Okay, so for example number 6, let's say we have this E, okay, raised to ln of 5, and what do you think? What will be the value? Alright, so let's try to answer this. Again, since we have this E as our base, okay, which is a natural number, so that is equals to 2 point something, okay? So, again, we have this exponent as ln of 5, and that ln of 5 is actually equals to logarithm of 5 with the base of E, okay? That is a natural logarithm, okay? That means if you want to transform this given expression, so let's transform this one. This expression is actually equals to E raised to the logarithm of 5 with the base E. Okay? And according to our property number 4, if we have this set of expression with common set of base, okay, we have this base as E, and its corresponding exponent, we have this same set of E, automatically the answer is the logarithm of the exponent, which is 5. So that is equals to 5. Okay, so let's try to double check this one. Okay, so for our checking, again, let's transform this given set of exponential expression into its logarithmic form. Okay, that is logarithm of a number. Okay, so we have this 5 as a number with the base of E. So this is our base, and that is equals to their, or to its exponent. So our exponent is obviously logarithm of 5 with the base E. So we have this logarithm of 5 with the base E, and that is equal, therefore our answer is correct. So the answer is 5. Okay, that is our example number 6. Next, example number 7. So for example number 7, let's try to solve this one. Let's say we have this logarithm of a fraction. Okay, so let's try to use 1 all over 36. Logarithm of 1 all over 36 with a base of 6 is simply equals to what? Right, so let's try to apply, I think that is for property letter C. So let's try to apply our third property. Okay, since we have this logarithm of a number, we have this 1 all over 36. Let's try to transform this value into its exponential form. Okay, and let's use the value of 6 as the base. Okay, that means it will give us, again, the value of 1 all over 36 is simply equals to 1 all over, I think that is 6 raised to 2. Okay, and 1 all over 6 over 6 raised to 2 is simply equals to 6 raised to negative 2, right? So that is according to the property of negative exponents. Since the exponent is negative, we need to flip that value and change the sign of the exponent. Since we have this 1 all over 36 as the value of our logarithm, okay, or the number, that is simply equals to 6 raised to negative 2. So let's rewrite our given problem. That means it will give us logarithm of 1 all over 36, or simply 6 raised to negative 2 with a base of 6. Okay? And according to our third property, if we have this common set of values again, so let's cancel out or disregard those values, and the answer for this given problem is automatically the given exponent, and that is negative 2. Okay, so that is the answer. So let's try to double check this one again. So for our checking, again, let's transform this logarithmic form into its exponential form. So that is equals to the base. We have this base is 6, okay, raised to an exponent. So our exponent is negative 2. We have this negative 2, and that is equals to the logarithm of a number, and that number is 1 all over 36. Okay, so let's try to double check this one. So by the way, I'm using our original expression. Okay, so our answer is negative 2. So I'm using our original expression. So we have this 6 as our base. The exponent is negative 2. Okay, and that is equals to the logarithm of a number, and that number is 1 all over 36, or the logarithm of a. So this is a. So let's try to simplify this. Since we have this 6 raised to negative 2, again, that is a negative exponent, we need to flip the value and change the sign of our given exponent. That means it will give us 1 all over 6 raised to 2, and that is equals to 1 all over 36. Again, 1 all over 6 raised to 2 is equals to 1 all over 36, and that is equals. That means we have this correct set of answer. Okay, so that is for example number 7. Next, for our last example, example number 8. So let's try to solve this one. Let's say we have this logarithm of a number, so that number is 1, okay, with the base of 1/4. Right, so again, according to our property letter B, okay, so for our second property, if we have this logarithm of a number and if that number is equals to 1, automatically the answer is equal to 0. Okay, so that is according to our property letter B. So if we want to double check again, just transform this given logarithm expression into its exponential form. So let's transform this one. Right, so just copy the base. Our base is 1/4 raised to our exponent. Okay, so our exponent is the outer value, which is 0, and that is equals to the number, which is 1. Again, according to the 0 exponent or the properties of our exponents, if the value for our exponent is 0, okay, any number raised to 0 except 0, the answer is always 1. So 0 or 1/4 raised to 0, that is equals to 1, and that is equals to 1. Okay, since that is correct, automatically we have this correct set of answer. Right, so that is our topic for today. That is for the basic properties of exponents. Thank you everyone, and God bless.